the question. What do you write down for this question? Oh, sorry. Excuse me. All right, let's see. All right, no chat. Let's get someone using their microphone to tell us, the brave one. Who wants to volunteer their answer for this? So first you have to tell me, is it true or false, right? Then, like the instructions say, if it's true, tell me why, right? Explain why it's always true. Or if it's false, give me an example that shows it's false. So someone want to volunteer their answer with their microphone? Uh-oh.
Dr. G.
Hey, Caleb.
Yeah, I got a question though. It's
Oh, so you don't want to volunteer your answer, you have a question.
Yeah, just to clarify something.
Okay.
When it says f and g are continuous for all of x, does that just mean that it's like a non-zero? Like it's a value up top?
Okay, can someone remind Caleb? Because we all know that Caleb didn't watch the video, Caleb.
No, this is 2.4.
No, this is you're asking about the continuity.
Yeah.
You just said, does f and g continuous for all? Does that mean, right? So you asked about the continuity.
Mm-hmm.
So Jacqueline says, I think it means that they're polynomials. So Caleb was specifically asking, does that mean that they're non-zero? And I think you had to say, it means there's a value for the function. I think that's what you were about to say, something like that. Sounded like that's what you were saying. So does anyone want to answer, Caleb? Yeah. So remember, it means a bit more. Continuity, first of all, continuity does not mean polynomial, right? There are many functions that are continuous that are not polynomials. Like, in fact, most of the functions that we deal with in this class that you're already used to, they are continuous. So e to the x is continuous, right? Sine of x is continuous. If I compose functions, it's continuous. So sine of x squared times cosine of x, that's continuous. Like Artsy said in the chat, continuity means you can use the direct substitution property, right? That's really what it means, okay? It means if I want to figure out the limit of the function, I can just plug in the number for that function. It does not mean, oh, the function is defined everywhere. I mean, if I say f and g are continuous for all x, yes, that does imply that f and g are defined everywhere. But being defined everywhere is not enough for continuity, right? You need this limit property, you need this direct substitution property. Okay, so good question. So does someone want to volunteer their answer then for this question? So that means f and g have the direct substitution property. So if I want to figure out a limit, that means I can just substitute the number into f and g. That's what it means, that first thing. And the second thing means that the limit of g is 0 at x equals a. So what do you think? Is the line x equals a necessarily a vertical asymptote? What do you think, Thomas?
I don't think so, because if they're continuous, then how could there be a vertical asymptote there? It would have to be infinite for there to be an asymptote.
Okay, so let's answer that question. So Thomas said false, not necessarily a vertical asymptote. And then he was questioning, well, if f and g are continuous, how could it be that you have a vertical asymptote, right? So the correct answer is false, but that's the wrong reasoning. Let's try to see why that's the wrong reasoning. Can someone give us an example that shows us we can actually have a vertical asymptote, right? Because Thomas's argument was there's never going to be a vertical asymptote. That's essentially what Thomas was saying, right? Can someone give us an example where we would have a vertical asymptote? So I'm going to actually say that here kind of in red. Note. The statement is sometimes true. Not really, because the word necessarily is there. I'll just say note, it is possible to have a vertical asymptote. Let's see, do we have something in chat? 10x, okay, that's fine. Let's see, so an example of that would be, okay, let's let f of x be sine x. Let's let g of x be cosine of x. And let's let a equal pi over 2. So this example, does that satisfy this? Yes, f and g are continuous. Sine of x and cos of x are continuous. G of x is 0 at a equals pi over 2, right? Cosine of pi over 2 is 0. However, the limit of this function but x equals pi over 2 is a VA for the function sine of x over cosine of x. So it is possible to have a vertical asymptote, right? In fact, we've actually seen in the section on 2.4, if you plug in the number and the denominator is 0, very often you do have a vertical asymptote. But the question is still false. Isn't there a hole in the numerator and denominator? Not quite, because at pi over 2, that actually kind of is a segue into the next question. At pi over 2, sine of pi over 2 is 1, and cosine of pi over 2 is 0. So if I substitute a equals pi over 2 into this function, I get what? I get 1 over 0.
I'm sorry. Oh, sorry.
Go ahead, Simon.
Oh, I think
Did I misunderstand your question?
I think I mistyped it. I think I meant like if there is a hole in the numerator and denominator, in that case you would get 0 over 0, and in that case f of x over g of x would not be the vertical asymptote, in which case you would have to cancel factors out, and the remaining function is where you plug in those two zeros from the denominator, and then you see which one is not 0, so that would be the vertical asymptote.
Okay, very good. All right, good. So everyone hears what Simran's saying, right? Simran was saying, so first of all, she's saying this statement is false, right? The x equals a is not necessarily a vertical asymptote. And what was her reasoning? Her reasoning was, well, what if I plug in x equals a? Okay, I get 0 in the denominator, fine. But what if I get 0 in the numerator also, right? That's the key here, right? If I get non-zero number, right? In this case, this example I gave, it was 1 over 0 if I directly substitute. And we learned that what? If you get non-zero over 0, absolutely a vertical asymptote, absolutely. But what did we learn about 0 over 0? What Simran just said. We learned that 0 over 0 could be either or. 0 over 0 can go any way you want, right? So that's the key to understanding this question. So the key is false, right? The point here is that if the numerator is also 0, so if f of a is 0 also, then we may not have a vertical asymptote. And Simran didn't give a specific example, but she did indicate to us how to find one, right? Simran said, if you want to find something like this, just choose F and G so that they have like common factors that cancel, right? That's the idea. So let's do, what's an example of this? Now, the easiest example would just be, okay, choose f of x equal to x and choose g of x equal to x, and those common factors cancel. But I think sometimes some examples are so simple, sometimes they kind of go over your head, or like it's like you don't see the forest for the trees, you know? So I think I like Nicole's example a bit more. So I'm going to make the numerator, let's make it x squared minus 4. G of x equals x minus 2. And then we're looking at a equals 2. So first of all, is this a counterexample to the question? So let's check. Are f and g both continuous? Yes, they're both polynomials. So yes, they are both continuous. If I do the limit of g as x approaches a, do I get 0? Yes, obviously if I plug in x equals 2, I get 0. So that's yes. Now, is this true? No. So this does serve as a counterexample. And let's see specifically why this is not a vertical asymptote. Well, just compute the limit. Right, we get cancellation, right? Everyone knows difference of squares. So we cancel, we get x plus 2. And then I substitute and I get 4. The limit is not infinite, or the limit is finite. So x equals 2 is not a vertical asymptote. Okay. So the point of this problem is would we have to type all this in a text box? No, you don't have to type this if you don't want to. You can type this part in English, and then you can do exactly what Nicole just did. You can tell me f equals x squared minus 4, g equals x minus 2, and a equals 2. I think you can do that all just on your keyboard, right? You don't need this math quill thing that everyone didn't like. So the point of this problem was to make sure, do you understand this fundamental concept of vertical asymptote, that denominator equals 0 does not mean vertical asymptote, right? Vertical asymptote is really intrinsically linked to, is one of the one-sided limits infinite, right? Vertical asymptotes go hand in hand with infinite limits, right? They do not go hand in hand with denominator equals 0, right? So that's kind of what this question was testing. And that really is an important thing, right? Because all the limits we've been doing up until now, other than the vertical asymptotes, really do have this cancellation. I mean, right?